Hi and welcome to this video on the lead and copper sensors. So it's fantastic that one of our users has reached out to us. I just want to kind of say that very immediately you're going to find there's a QR code update. In fact, I've got the QR code in front of me and I will link the video to the QR code update. So just FYI, that QR code has been updated a while back, but this person's just started using the system, so there is a QR code update. And what I mean by a QR code update, that will all become really clear in a minute. But I do have a sensor all in front of me. I do have some lead sensors. I do have also some test solution. I will be doing a live demonstration. In fact, let me start that live demonstration now, because I realize that the one thing about this assay is we love to make fast assays at Zimmer and Peacock, but this assay does take 4 minutes. So I'm going to actually dive straight into it and do the assay now. So I'll take the sensor, it's one sensor per test. The new QR code, when I scan it now, means that this is a copper or lead and copper assay at the same time. And I'm going to give this sample a name. So I will put test lead. Test lead. I'm going to put test lead in this. Right, so I can do copper and lead at the same time, and I'm going to grab a 50 microliters of the sample. So the sample, for me, I've taken 1 volume of the sample and added 1 volume of the buffer. So buffer comes with it. It's probably worth saying that, I'm going to only use something like 50 microliters of the buffer. So this buffer will last for ages. Then I've taken 1 volume of the sample, 1 volume of the buffer. So let me take that sample now and put it onto the sensor. So this is 50 microliters. I put that onto the sensor like this. Now what I'm going to do is name it in the, I've named it in the app, PPB. This means that later on now I can essentially, this means later on I can actually find the data. Right, and now we'll hit continue. So I will hit continue. I will drop down the menu and tell it that this is a 1-in-2 dilution, because I've taken 1 volume of the sample, 1 volume of the buffer. I will talk about the dilutions a bit again in a minute. And now that's started. So I've started that. So it says here 2 minutes 42, 2 minutes 40. So yeah, it's a 4 minute. It's definitely a less than 5 minute assay. So off it goes now. And that's very bright, I know, so it's kind of hard to see. But what it's doing now is it's grabbing the data in real time. It's giving me a progress bar. But as I say, that will take about 4 minutes. So now having started that assay, I will share my screen with you and go through the rest of the webinar. Right. So they're really looking for procedures, so let's discuss this. So the question, is calibration required before measuring an unknown sample? The answer is no, calibration is not required before measuring an unknown sample. Now the only reason we get away with what's called global calibrations is because we make a very reproducible electrode. If we weren't doing that, then there would be a problem. So the quick answer is no. Is the system already calibrated? What's the range? Right, so the system is already calibrated in terms of the system is calibrated to work with these particular electrodes. And what's the range? Okay, so we have a series of dilutions, and I'm going to show you in a minute that the software allows you to choose. When it says 1, it's a bad name, and 1 means that there really is no calibration. So I have seen people misinterpret that, and that's our fault. Then it says 2, that means a 1-in-2 calibration dilution. Then it says 5, that means a 1-in-5 dilution. So 1-in-5 dilution means 1 volume of the sample plus 4 volumes of the buffer. Then it says a 1-in-10 dilution, or 10. That means 1 volume of the sample and 9 volumes of the buffer. And then it offers a 1-in-100, which means 1 volume of the sample and 99 volumes of the buffer. Now the reason I bring that up is because you can understand that by using those different dilutions, we can deal with quite a range of concentrations. Now, when we started this assay, it was a little bit unclear what lead concentrations are we dealing with? And what I mean by that is this. Drinking water in the US and Europe people are interested in measuring things like 4 parts per billion or 5 parts per billion. And therefore, actually, that's quite low. So we don't want to use a high concentration. But if somebody's using this in a sort of mining operation where maybe there's, lead mining, for example, yeah, the lead would be really high. So there you could understand that you'd want a 1 in 100 calibration. So we have quite a dynamic range. But we introduced the sort of the 1 in 2 dilution because actually a lot of drinking water applications are really, the lead is actually quite dilute in those applications. Is the lead buffer mandatory to be added to the sample before analysis? It's not. Right, okay. The quick answer is most water has an unknown pH and has an unknown ionic strength. So most water has an unknown pH and unknown ionic strength. Understand that when we add our buffer, we are reducing that unknownness because essentially our buffer has an ionic strength and it has a pH. And so when we do that, we are now controlling what's otherwise an unknown parameter. The reason that we have an opportunity to not dilute at all is called the white 1 is because water companies often have the samples already prepared in quite an acidic medium, and therefore they don't really need to do the dilution and etc. But most of the time, yes, you do need to add some buffer, either 1 + 1 or 1 + 4 or 1 + 9 or 1 + 99. Right, this is just coming to an end now. So I'm just going to change the screen for a second because this is just coming to an end. And then we'll get back to the questions in a minute. So now what it's doing is it's actually doing the analysis now. It did what's called the deposition step, and now it's doing the analysis step. I can see a little bump there, and it will analyze that little bump in a minute. What it does, it sends the data to a cloud system called Julie, and it's given me a answer. So I've got my lead at 61.3 and my copper at 381, but I just want to show you what that now means. So I'm just gonna go to here and I'll just share my screen with you for a second. So I'll come into here, I'll take my solution, I'll do a quick refresh here. I'm just refreshing here. I'll go my test PPB. So the good thing about the Sense It All is that it not only gives you a value on the phone, so you get this kind of, somebody's a field engineer and, they just want the result. It also allows scientists to actually, go in there, lab scientists to go in there and really analyze what's going on as well. So what I can see here is I can clearly see this is the lead value that it gave me on the device, and I can see the raw signal, and I can see the way it's analyzed the data as well. So you can see that it's really found a nice peak and found the peak height, and it's turned the peak height then into concentration. Now the reason I bring this up is because you can understand that I'm at the moment in the ppb range, and this will become pertinent in a bit because this person's asking about the ppm range. Just FYI, if you are a kind of quality manager or you need to share this with, because you need to share this with colleagues, but you don't want them to give them access necessarily to the database, you can export as a PDF. So you can essentially, capture all of this as well. So now what I'm going to do is I'll go back to the main questions, but I just wanted to kind of show you that as well. So there it is there. So then you get a PDF, and it's got, in fact, I might just emphasize that those reports have the time, date, name of operator, raw signal, and the value. So you've got a really great traceability in this system that you wouldn't normally have. So name of samples at the top, time, date, name of sample, time in date, operator, raw signal, and the actual calculated value as well. Just notice that my peak current here is in the microamp range, so I really strongly suspect that this person's current who's asking these questions today is must be really high. But let me go back to the questions. Right, so now let me just do a quick recap. Is calibration required before measuring the unknown sample? No, you just saw me. What I've done is I've taken one volume of the unknown plus one volume of the buffer, so that allowed me to then sort of control the pH and the ionic strength of that sample. I didn't do a calibration because as long as I'm sort of following my protocols and I'm using these electrodes, then I can use what's called global calibrations. The lead buffer, I would say 99% of the time, is mandatory. The only reason we've got an opportunity to not dilute, and that's in the drop-down menu, and you'll see that in a minute. There's a drop-down menu and we can choose one. It's because there are some water utility companies where they've already prepared the samples and therefore we just take the sample as is. But most of the time in the real world, you've got an unknown sample, you've got the buffer. If you think the unknown sample is dilute, then it's 1:1. If you think it's a bit stronger, it's 1 plus 4. If you think it's a bit stronger, it's 1 plus 9. And if you think it's really strong, it's 1 plus 99. I know you say, well, I don't know what that's going to be, but the system these days will actually say, it will just say high on occasion. So sometimes if there's too much lead signal, the result coming back was just say high, and that will encourage you then to dilute more. Can the sensor be reused or just single use? It's just single use. You know, at this point now, it's very hard for us to argue that we can get all of that lead and copper off that sensor. So they try to prepare a 1 ppm and a 5 ppm. Those are very high concentrations. Whoops-a-daisy. If I was going to test that 1 ppm, I would be taking something like 1 volume of the 1 ppm, adding 9 volumes of the buffer, and essentially that's a 1 in 10 dilution. And you will see me deal with that menu in a minute. So there's a new QR code. I will link to this QR code underneath this video. When you scan it from the app, you should get, say, lead and copper. When you hit continue, it gives you this menu. So the 1 dilution here means there actually is no dilution. It's not very well worded, but that's for people who are water utility companies. They've already prepared samples and they just want to test the already prepared sample. Now, if you're in the field and you're doing testing of water, and I just like tap drinking water, then I suspect you would end up using 1 volume plus 1 volume of buffer, so that's a 2. If it's higher, you would use 1 volume of sample plus 4 volumes of buffer, so that's a 5. If it's really high, it's 1 volume of sample and 9 volumes of buffer, that's a 1 in 10. If it's really high, and this must be extraordinarily high, 1 volume of sample and 99 volumes of buffer, and then you can hit start and off you go. So in summary, you don't need to calibrate unknown samples. The range is, the range is this, that we can use dilution to essentially, what the system does is the higher the concentration, the more dilution we use. If you're not done enough dilution, it will just say high for you, and then you can actually increase the dilution. Is the lead buffer mandatory? 99% of the time it is mandatory. The sensor can be reused, it's single use. For your sample, let me focus, that 5 ppm is very high, by the way, especially for lead. But 1 ppm is an easy piece of maths for me. What if I take 1 ppm and you do essentially a 1 plus 9, that will bring that to 0.1 ppm, which is 100 ppb, and make sure that you tell the software that was a 1 in 10, and it should be able to deal with that then at that point. If you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.